Hey, what's up, guys? It's back at it. We back at it again. It's July 4th, 10:40 p.m. This morning I tutored a kid, uh, taught him some math. Pretty productive morning, and then did the lecture on multi-cycle processors. I haven't finished it yet. I finished the first half. Pretty interesting. So the main difference between single cycle and multi-cycles, obviously is in single cycle, one instruction takes one clock cycle to finish. And the main drawdown of that is the clock cycle has to be longer than the slowest instruction in the ISA, right? However, with multi-cycle, you can break the instruction into different clock cycles. So the clock period is no longer constrained by the slowest instruction. Instead, it is constrained by the slowest stage, right? So essentially, you're breaking the instruction into like the six different stages of instruction processing. So like fetch, decode, load operands, evaluate addresses, execute, store, right? Um, so you're breaking each stage into a different clock cycle. And the main drawdown of that is that you pay the overhead per instruction multiple times, right? Because single cycle, you only pay the overhead once. So you have to care about setup and hold down timer only once per instruction. However, with a multi-stage instruction, because you're splitting each instruction into different stages, and different clock cycles, you have to pay that per cycle, right? Um, so that's a downside of multi-cycle. And another downside would be what is it? I forgot. Hmm. Oh, right. So the ALU and the control unit has to be extremely complex compared to single. And you have to store intermediate state results. I think that's the biggest thing, right? Because single cycle, you don't have to store intermediate results, because everything finishes in one singular clock cycle. However, with multi-cycle processing, um, you have to transition from one state within the FSM into another state, and therefore within the transition you have to store an intermediate result. So therefore it results in a lot more registers in a multi-cycle processor compared to a single cycle, right? Yeah, high overhead, we talked about this. Yeah, and I think those downsides will lead to pipelining a instruction. Um, But yeah, so that's what we learned today. The lab that I have to do is implementing an ALU within the multi-cycle processor. So not exactly building out the whole processor yet, just building the ALU. But that already itself is a monumental task. I don't really know how to do it, if I'm being honest. Still learning. But yeah, I feel like I'm on a good track. Something that I don't really understand is like, what's this role of a software engineer within a trading shop? Because like the critical trading infrastructure is all done by hardware, right? ASICs, FPGAs, it's all done over there. Then what's the role of hardware? Sorry, what's the role of software within all of this? Like network connectivity, like monitoring, like front end stuff, like Grafana, trading desk operations. Is that what it is? Um, I'm not sure. Like, I need to ask people who are actually working in HFT, um, to actually understand more, I guess. Um, yeah, I guess I can start with Reddit as well to learn. Um, yeah, I guess I can ask. So assuming all core trading logic is done, in the hardware in HFT. What is the role of a Swede within a trading company? What software do they build? Give me some specific examples, I guess. Okay, and for the legal part of today, I don't want to do the difficult Nico questions because it's like I just don't want to do it. I'm just lazy today, right? Um, so we're gonna do this, which is an easy question, which was the daily question for yesterday. So let's just do this. This guy is super impressive, like very good guitar player. Yeah, I do want to know about this though. Market data feed handlers. Okay, this is what I heard as well. So a lot of people who recommend C++ projects for HFT start with market data feed handlers. I always assumed this was done in hardware. Um, and I'm pretty sure they are. Swedes develop software to receive, process, and normalize high volume market data from exchange. This software ensures the hardware trading system gets clean, structured data with minimal delay, enabling fast decision making. But I think this is still written in Verilog, no? Like directly on the ASIC or directly on the FPGA. Okay, needed to configure the hardware, set trading parameters, and manage strategy deployment. That will be written in Verilog, no? Oh, but you have to be able to tune it while it's running, right? You can't just turn it off and turn it back on. Like that's not an option. So maybe you need some sort of software for that. Interesting. Monitoring and visualization tools. Swedes create real-time dashboards and alerting systems to provide visibility. Okay, yeah, so monitoring stuff. Yeah, I guess tracking is a very important thing in high frequency because order management, right? Like you don't even know what orders you're placing. So that has to be very accurately reflected in the front end dashboard um, for people, for the traders to, do things. That load. Let's work on this. Alice and Bob are playing a game. Initially, Alice has a string word A. You're given a positive integer K. Now Bob will ask Alice to perform the following operations forever. Generate a new string by changing each character in word to its next character in English alphabet and append it to the original word. Okay, for example, performing the operation on C generates CD, and performing the operation on ZB generates ZBAC. Return the value of the kth character in Word after enough operations have been done to have at least k characters. Okay. I'm thinking there is a vector of characters, alphabet, right? Size 26. And then uh God. Hello? Okay, bye. Give me a second. Okay, we're back. I don't think we have to do this. I think we just do right, there's a string. We call it word. It's just a while word dot length is smaller than k, right? Um, while smaller than k, I want to word dot append a thing. Let me think. This is oh, you can write this logic within the hardware and then give a software interface to control it, maybe? Okay, that would be a project that I have to do at some point. But let's just finish this and call it a day here. I'm just very tired, to be honest. Modifiers. There's a pen, right? Yep. Word dot append for character C word word dot no. And I equals to 0, I is 1, and plus plus I, word dot append, um, word I, uh, plus minus this. How do I do so I have these, right? Decimal 97 till 122. So if I have 98, that's fine. So it should be 90, so it should be whatever the thing is divided by, it has to go back to 97. So it would be 122, plus 1 remainder 192. So whatever these are, I'll be fine, right? And then let's say 123 remainder 122, it'll be 1. Oh, I don't have to do this. If word I equals to said, right? Then you just word append a instead, right? That seems like the most easy solution. Else you just append word I plus 1. It's bait. I mean just plus equals, right? That could be K minus one, maybe. AB, ABBC. So I should return this, which is the fourth index, right? Yeah, Jesus. My dad is drunk. Um, yeah. Um, what would be like the best solution? What does this mean? Yeah, I'll never think of a shift solution. That's crazy. Um, yeah, whatever. I'll just call it here. I'm so tired, guys. Um, yeah, this will be pretty cool, I guess. Yep. Anyways, yeah, I'll call it a day here. Peace, guys.